All right, the next part we're going to talk about in our notes is the other characteristics of quadratics. So yesterday we talked about the parent function of a quadratic graph. We talked about the transformations. We talked about how to graph a quadratic, how to find the transformations, how to find the vertex, and how to use all of that, including your calculator, to find the best points to graph. And so now we're going to say, okay, once you've done all of that, what are the other ways you can describe a quadratic function? So those are the other things I call the characteristics of a graph. So the next thing that they might ask you about a quadratic is what the domain and the range are. So for example 3, the first thing they ask you is the vertex. So we can do that because we already did that on the previous page. So the vertex for example 3 would be -5, -6. And then the domain is all of the x values in the function. So for the domain, we look from the left side of the graph to the right side of the graph. So if I look at this picture, I can see that the very left side of the graph is an arrow. The furthest to the left that you can go is this arrow right here. And the furthest to the right that we can go is this arrow over here. So anytime we have arrows on the graph, that means they're going forever, and the number that we use to represent forever is infinity. So this goes forever to the right, and we know that if we look on the right side of our graphs, that's where all the positive numbers are. And so an arrow going to the right would mean positive infinity. An arrow going to the left would mean negative infinity, because that's where all the negative numbers are. So if we wanted to write down what the domain was, we would say that all of the x values represented in the graph are negative infinity all the way to positive infinity, because if we start from the left and go all the way to the right, we start at negative infinity, and then we have all of the x values all the way to positive infinity. So our domain is negative infinity to positive infinity. In fact, the domain for every single graph in this particular unit is going to be negative infinity to positive infinity, because they're all the same shape. They're all that U shape, right? Next, we have the range. I'm going to go ahead and write the x down here. This is left to right. Next, we have the range. The range is from the y values. So for this, we're going to go from down to up. We're going to look at the bottom of the graph first, and then we're going to look at the top of the graph. So the bottom of the graph stops at the vertex, and it stops at a number. The number that it stops at is -6. So the very bottom of the graph is at the vertex. That's at -6 right there. The top of the graph has arrows that are going up forever. So the top of the graph is going up to infinity, positive infinity, because it's going up. So if we were to write the range, we would say we start at -6, and then we have all of the y values from -6 going up forever, up to positive infinity. For infinity, we always put a parenthesis, but the -6, if you said, Miss Rice, where's -6? I would say here, it's right there where I put the dot. That's where the -6 is. And anytime I can do that, we put a bracket around the number. All right, so that's the domain and the range. Next, we have the increasing and the decreasing intervals. So these are both x values. They're x values that make the graph go down, so they make it slant down, and x values that make the graph slant up for increasing. So what I like to do is I draw my stick figure, and I always draw him on the left side of the graph. I read from left to right, just like we read books. And I think about if he is walking uphill or if he's walking downhill. So if I look at this picture, my stick figure right here is walking downhill. So I'm going to say this right here is where the stick figure is decreasing. And then he gets down to the bottom, he gets down to the vertex, and that's the bottom of a valley. And then from there, he starts increasing. He starts walking uphill. So this is the increasing, right? And so what I want to do now is I want to write down the x value where he started, the x value where he ended, and the x value right in the middle where he switched directions. So the x value where he started is a left arrow, so that's a negative infinity. The x value where he ended is a right arrow, so that's a positive infinity. The x value in the middle where he switched directions is the vertex. It's the x value of the vertex. So I'm going to pause what I'm doing. I'm going to look back at the equation, and I'm going to find the vertex. So this equation, 3/2 times x minus 5 squared. There's no number on the end, so I'm going to go ahead and put a 0 on the end so that I have a number in both spots. So I can go ahead and write my vertex. So my vertex would be positive 5, 0. Oops. Okay, so now I have my vertex, and now I can say I'm going to use the x coordinate of my vertex, the 5. And so now I can write my answers for increasing and decreasing. So the word increasing is in between these two numbers. It's from 5 to infinity. So increasing is from 5 to infinity. Infinity always gets a parenthesis. Now 5 would only get a bracket if the moment when the stick figure is standing there, he would actively be walking uphill. So if the stick figure is standing at this point exactly, is he walking uphill? And the answer is no, he's not really walking uphill or downhill. He's kind of in between. That's like a neutral position. And so here we would use a parenthesis for that. We would say for the increasing, it's parenthesis, parenthesis. And what a lot of students like to do for increasing and decreasing is they just say, well, if that's the case, I'm just always going to use parentheses, and that's totally fine. If you want to say domain and range are the only answers that get brackets, and increasing and decreasing always get parentheses, that's okay with me. For the decreasing interval, we look at the word decreasing. That's in between the numbers negative infinity and 5. So we're going to write those numbers down. Negative infinity and 5. Infinity always gets a parenthesis. And then for 5, we look and we say if the stick figure was standing right here, is he actively walking downhill? And the answer is no. He's kind of in between. He's not going downhill. He's not going uphill. He's in between. And so we use a parenthesis. All right. The next thing we can find is a maximum or a minimum of a function. And the maximum and the minimum, they just look like mountaintops or valleys. So a maximum looks like a mountaintop. Mountain top. A minimum looks like a valley. Now for this unit, when we have these quadratic graphs, you will not have both. You will have one or the other. And so one of these answers, every single time we do this for this unit, you're going to have to say none for one of them. So for this picture, it's very faded. You can't quite see it. But for this picture, this quadratic is upside down. And so it has a vertex right up here. There's the graph, if you can see it a little bit better if I trace it. So this one has a maximum, it has a mountaintop, but it doesn't have a valley. So for minimum, I would say none. For maximum, I would find the vertex. The vertex is -5, +10. So -5, +10 is the mountaintop. So that's the maximum. All right, on to the next page. Next, we have our x-intercepts and y-intercepts. So I'm going to show you guys how to do these on your calculators. If you are doing this at home, you can just use Desmos. But if we're doing this in school, we're going to practice this using our calculators so that we know how to do it on the TI-84s. Sorry, I had to grab mine real fast. So I'm going to graph that particular quadratic. Just going to clear my calculator first. So I have to type in the function. So I'm going to press the y equals button. And I have to graph the square root of 2. So I'm going to press the second button. And then the x squared button, that's how I get a square root on my calculator. So there's the square root of 2. And then I want x minus 1 squared. So x minus 1 in parentheses. My parentheses are above my 8 and my 9. So, and then here's my x button. X minus 1 squared. And then I need a minus 8. Okay, so if I hit the graph button, I'll be able to see the picture, and it should look exactly like what you have on your paper. And then for us to get the x-intercept, the way that we get to the menu on the calculators is we hit second trace, and the x-intercept is number 2. So we're going to write that on our papers. Second trace, number 2. And the first x-intercept looks like it's around like negative 1.5. And so whenever I can see my first x-intercept is over here, I always tell my calculator to look between negative 10 and 0. That's just my habit. I say like, hey, look over here on the whole left side of the graph. I call the left side of the graph negative 10 to 0, and I call the right side of the graph 0 to 10. That is just my habit. So anytime the graphs work like that, that's what I do. So I'm going to use negative 10 for my left bound and 0 for my right bound. So I'm telling my calculator, hey, look between negative 10 and 0. The guess is never good, so I'm just going to press enter to get past that. And then here is our x-intercept, negative 1.378. Now, you could be a little bit more accurate with your guess. Like you could say if it's negative 1.5, then technically that x-intercept is between negative 2 and negative 1. And you'd find it. So there's a lot of numbers. You could tell the calculator to look between negative 3 and 0. So the calculator can find it using a lot of numbers to look between. You just have to choose numbers it's actually between. So I don't like to have to squint to look at the calculator screen to really see what it's between. I just go like, oh, it's on the left side. Let me look between negative 10 and 0. And that seems to work for me. Okay, so my first x-intercept is negative 1.378, 0. My second x-intercept is on the right side of the graph, and so my way of doing it would be, hey, calculator, look between 0 and 10. It's somewhere on the right side of the graph. So I would do 0 to 10. Now, if you're at home and you're using Desmos for this, you found the answers really quick because you could just click on them. Okay. So there's those. Now to find the y-intercept, we do second trace option number 1, and we plug in 0. Second trace option number 1. And we plug in 0. So the y-intercept is negative 6.586. Negative 6.586. Okay. Whether the graph is a continuous curve, feel like I wrote this sentence awkwardly. If the graph is a continuous curve, you can trace the whole thing with your finger without picking up your finger. So U-shaped graphs are always continuous because you can always make a U without picking up your finger. So I made a special note down here. Quadratic functions are always continuous. So they are a boring question for this unit. End behavior is just talking about the arrows. So I'm going to remind you of something. I'm going to draw it down at the bottom here. I'm going to do this in two different colors. So we have x. There are two infinities that go with x. A left arrow is a negative infinity. A right arrow is a positive infinity. We also have two infinities that have to do with y. So a down arrow is a negative infinity. An up arrow is a positive infinity. So when we look at our graphs, our curves don't usually go straight up or straight down or straight right or straight left. They're usually slanted, which means that the arrow can point down and to the left or down and to the right or up and to the left or up and to the right, which means that we can use two different infinities to describe every single arrow. And so the end behavior is really just describing which direction the arrows are going. So the first thing we always write is as x goes to negative infinity. As x goes to negative infinity. This is a really fancy way of saying, hey, look at the left arrow. Then we say as x goes to positive infinity. This is a really fancy way of saying, hey, look at the right arrow. So when I look at the left arrow, I can see that the left arrow is pointing up. So if I want to say that it's pointing up, I'm going to say y, and I'm going to say positive infinity. The right arrow is also pointing up, and so I'm going to say positive infinity for that one as well. So this literally says the left arrow points up, the right arrow points up. So left arrow points up. And then over here, this says right arrow points up. So this is how we say left. This is how we say up. This is how we say right. This is how we say up. So we're going to do the same thing for the other picture. For this picture, we're going to say the left arrow points down, the right arrow points down. So as x goes to negative infinity, as I look at the left arrow, I can see that the left arrow is pointing down. Left arrow points down. As x goes to positive infinity, I can see that the arrow is pointing down. The right arrow points down. That's all the end behavior means. It just means you're describing where the arrows are going.